Welcome to week 4 of quadratics. Week 4 means we've spent 3 weeks on this topic, and we've touched on pretty much everything that is a standard with it. We've done the vertex, we've done x-intercepts, y-intercepts, we found a few different ways to find the x-intercepts, we've used real life examples and graphed it. All right, but because we've touched on so many different standards, we've kind of raced through it a little bit. So I wanted to go back to what is probably the most important thing with a quadratic, which is solving the quadratic equation. When it comes to math, you want to solve problems. And when they say solve the quadratic, we need to know how to do that. So hopefully you remember that solving the quadratic means find the x-intercepts, set the y equal to 0, and solve for x. Now there's a few different ways to do that. One of them being factoring, and that's the easiest way if it factors nicely. Now, that's what we're going to spend this week on. So this week should be a little bit easier for you. We're going to dive a little deeper into factoring, which traditionally factoring is easier than the quadratic formula or completing the square. So today we're going to talk about the special product patterns of factoring. So they're special. They're a little bit. There's a pattern to them as opposed to the not special one. So I'll give you an example of one that's not special first. So sorry, problem, you're not special. But it just would be a simple x plus 3 times x minus 5. So if you had to turn that into a standard form, ax squared plus bx plus c, you would have to multiply those two parentheses together. And you're basically distributing both of these terms, the x plus 3, through that parenthesis. So you distribute the x through first. X times x is x squared, and x times negative 5 is negative 5x. And then you distribute the 3 through. 3 times x is 3x, and 3 times negative 5 is negative 15. And then you combine your like terms, which are your x terms, your negative 5 and your positive 3, and that combines to negative 2. So if you were given a quadratic formula in this form, and they said turn it into the standard form, which is ax squared plus bx plus c, you would multiply them together and get x squared minus 2x minus 15. And there's really nothing special about that. There's no shortcuts. Well, there are a few cases where it's considered special, and there's a pattern that's basically a shortcut. So here's your 3 cases. All 3 cases have the same number, 5. I just picked 5 in this one, but it could be any number. The point is, both parentheses have to have the same number. They don't have to be the same sign. One could be positive, one could be negative, but they have to be the same number. So here, that's why this one wasn't special, because you had 2 different numbers. You had a 3 and a 5. Here we've got all 5s. All right, if they're both negative, and we distribute just like we did in the non-special case, you would get x times x is x squared, x times negative 5 is negative 5x, and then distribute negative 5 to get another negative 5x, and negative times negative is positive, and then you combine your like terms and you end up with this, x squared minus 10x plus 25. So the shortcut here is you take the number, if your numbers are the same and the same sign, in this case both negative, you double that number and keep it negative. That's your b term, negative 10. And then you square it to get your c term. Done. So you can kind of skip that part, go right to there if you see the pattern. This pattern is basically the same thing. You're going to double your constant, your 5. It's positive, so now this is a positive 10x. Positive 5 squared is positive 25. So the only difference between examples 1 and 2 are your b term. If your numbers are both negative, your b term is negative. If your numbers are both positive, your b term is positive. And then the last one is if you have one of each, a negative and a positive. When that happens, you distribute your x through. X times x is x squared, x times positive 5 is positive 5x, and then you distribute your negative 5 through and you get negative 5x minus 25, because a negative times a positive is a negative. Now you combine your like terms and they disappear. A positive 5x and a negative 5x, that's 5 minus 5, that's 0, 0 x's. So your b term's gone, and you just have x squared minus 25. So that's the lesson for today, and that's what your problems are going to be like. All your problems in the homework are going to be in one of these three forms, and you're going to have to put them into the standard form. You're going to have to multiply them out. You might see 1 and 2 written like this. You might see 1 presented to you as opposed to x minus 5 times x minus 5. You might see it as x minus 5 squared. When you see it like that, think of when you square something. Think if it was 4 squared. 4 squared would be 4 times 4. 4 squared is the same thing as 4 times 4. Well, x minus 5 squared is 2 parentheses that are x minus 5. X minus 5 squared is this, x minus 5 times x minus 5. You just take 2 of those and multiply them together, just like you took 2 4s and multiplied them together. So your problems on the homework are either going to be presented to you as already 2 parentheses that are exactly the same, or they'll say 1 parentheses squared. They mean the exact same thing. All right, if it's like this, where you have 1 is negative and 1 is positive, you're not going to see it squared because they're not the same. One's negative, one's positive. So there is no other way to write this. So if it's presented to you as problem number 3, it's going to look just like that. All right, so that's your homework. One of these 3 types of problems, multiply them out to put it in standard form, and then later in the week, your homework will be presented to you as one of these 3 forms, and you have to factor it. You're going to have to work backwards. You'll be given this equation, and you have to write it like this, or you'll be given this equation, and you have to write it like that in factored form. So all week, that's what we're going to be doing. Special cases of factoring, special ways to find what x is equal to when y is equal to 0.